Alright guys, how is everybody doing? Hope everybody's having a good third week of school. Let's talk a little bit about constellations and the specifics you're going to need to know for this chapter. What is a constellation? It's a group of stars making an apparent pattern in the celestial sphere called a constellation. And the celestial sphere, as we talked about today, is kind of like the globe that goes around the Earth, right? So if this is the Earth, the celestial sphere would be this kind of imaginary globe that surrounds us in every direction, right? So it's the sky, it's the sphere that surrounds us in the sky. And the constellations would appear to be these like little dots that appear up here, right? And then we make little shapes out of them and stuff. Okay. Greek philosopher Homer, who wrote the Odyssey, mentioned a few modern constellations in the Odyssey. The first constellations were written in history during the Mesopotamian era, during 4000 BC. Ptolemy mapped around 48 constellations, but most were in the northern hemisphere. In 1589, Dutch astronomer Plancius filled the southern void of the constellations. So the reason why Ptolemy was only able to do the northern latitudes is because if you're beyond this line on Earth, the bottom half of Earth would occlude or get in the way of the sky below us. You know, the Earth isn't clear or see-through, so you wouldn't be able to see this stuff down here. And since Ptolemy was somebody in northern Europe, this would have meant that he couldn't have seen stuff down here. Here are the 88 official constellations. Here, get all those, quick. Just kidding. You'll have to know a handful of these, but you don't need to know all of them. It's interesting noting that most of the northern hemisphere constellations are going to have like Latinized names. And not that they don't exist on the bottom half too, but you start seeing stuff like Chameleon and Sea Dragon on the southern hemisphere. It's pretty interesting. Okay, constellations in astrology. You're going to want to know these and write these down because we're going to do a little. You'll have to be able to identify these constellations, so you want to make sure that you copy these down in your notes now. So you got Aquarius, Pisces, Aries, Taurus, Gemini, Twins, Cancer, it's the crab, Leo the lion, Virgo, I'm not sure, I don't remember what all of these mean. Libra, I think scales, Scorpio is scorpion, Sagittarius is an archer, Capricorn. There you go. So you can use the Big and Little Dipper to be able to identify where these zodiac constellations are at. So look at the Big Dipper, you can identify this in the sky as like this really big kind of pail that you would put water in. And you can see like the star at the corner will point directly to the North Star here in the Little Dipper. And the little handle of the Little Dipper's Polaris is our North Star. Over here we got Regulus, part of Leo. So you're going to want to be able to identify some of the biggest stars in the night sky and which constellations they're in. Okay, so take a look at that. You want to draw this and just make sure you have it. Okay, the celestial sphere. So this is kind of like the sky map that we have over us. And you can see Polaris, the North Star, because if we were to take a long exposure camera shot and see that these stars are rotating east to west, west to east. Let's see. I think it's going this way. Yeah. You can see that a night of circulating, rotating the night sky, Polaris stays in the center. And that's why it's the North Star, because it is in line with the axis of the Earth. So if I go like this, and I were to get, where are you at? Come back here. The axis of the Earth, about 23 degrees tilted from normal. That's about 23 degrees. This right here would point to a star, and as the Earth rotates, the sky would rotate around it too. All these stars would also rotate. But since this is right dab smack in the middle of that axis of symmetry, that North Star doesn't really appear to move. Okay, these are well-known constellations. You're going to want to know these, or at least know the names of them and the general shapes, especially the zodiac ones. Which one of these do you like the most? Which one represents you in some way, either because of your birth date or your birth month, or which ones do you know the mythology of a little bit? So locating celestial bodies using constellation. Scorpius contains the orange giant star called Antares. So here it is. So you're going to want to know that. Okay, so here's like the head of the body where the pinchers kind of come out and everything. You got like the body here. You got like this cool tail. And then here's the little stinger. That's more like a crab claw. There you go. So cool stuff, right? Okay, then we have the galactic core. You can see that the teapot constellation there, that's 3SGR. It's the galactic center. And right at the galactic center of the Milky Way, you have flanking it Scorpius right here. And you also have the teapot. Okay, so that's easy way to kind of remember where the galactic center is at. You can kind of look for this low in the night sky, this tail here, and you can see Scorpius. See if you can challenge yourself to go see that tonight. Crux is cross. And it's interesting that Christmas time usually coincides where the sun will actually descend and fall down on the cross constellation as it sets at night, the winter solstice. Kind of sounds familiar to a couple of religious stories, doesn't it? Interesting, right? Orion contains the bright orange star Betelgeuse, right in the shoulder here. And we learned that today when we were watching that video. Okay, Andromeda is the most distant object the human eye can see and is the closest, largest galaxy. So there it is. So if we look at the square of Pegasus, if you look slightly above it and to the right, you can see that the Andromeda galaxy is right there. So it's between Cassiopeia and Pegasus. Okay. Cygnus at Swan. So what does Cygnus look like? The first black hole ever discovered was in Cygnus. So it's right here, right at the base of the neck of the swan right here. You see the wingspan here and the tail? And right there. How can you tell something's a black hole from that far away? Isn't that kind of interesting? You can't really see it. It does not allow light to escape, so we can't actually observe it directly. How would you observe something that can't be seen? That can't be heard, that can't be touched, that can't be smelled? How would you know something even exists there? If all of space is kind of like a black void, how would you distinguish this black void among all the other black voids out there? The fate of constellations. So this is something you want to know. Because our solar system's motion through the Milky Way galaxy, stars will appear to move across the night sky over the course of several thousands of years. Closer stars will move faster, while farther stars will move slower. So imagine how the moon looks on a nightly basis, how it appears to move through the night sky. You couldn't count on the moon being in the same spot at all times. While the stars are so much further away to the point to where we can kind of depend on them for thousands and thousands of years, eventually, as we move through the spiral arms of our Milky Way. So if this is our Milky Way right here. So if we are here, we are actually kind of moving like this, right? We'll eventually kind of come around. Our vision of the night sky will change eventually, but this motion that I showed you here takes a very, very, very long time. Okay, so don't worry. We will all be gone long before we have to worry about the night sky changing. But it does happen. Okay? Stars have different velocities and distances, causing distortions in constellations. Okay, so right here we can kind of look at the Big Dipper as it has changed over a period of time. So as we move through the Milky Way galaxy, as these stars kind of change in their life cycle, you can see that the sky looked a little bit different in the past as it does today. So this is in the past, right? This is around our time. This is about 50,000 years from now. This is about 100,000 years from now. You can see that these things will become very distorted over time. Look at the Archer here, how it's going to change. And we only know that they're going to change because we know their stellar distances now, right? And that's kind of interesting. Most of the stars the constellations are separated by huge distances. So kind of like how I paused the video today and we zoomed in on the Pleiades, you can see that they're actually not on a flat plane. But if it's like if you were to look at something like Crookes here, right? And you were to turn it on its side, you were to rotate it kind of like this, you were to look at the stars from the side, you wouldn't see 4 stars in a line like that. You might see one here. 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 And these things don't line up at all, but when you flip it back around this way, what you would see is 1, 2, 3, 4. It would look like this. But there's a lot of depth to that picture. Okay, so why is mapping constellations so important in astronomy? Why have human beings used them in the past? How are we going to use them in the future? How do we use them now? What astronomer mapped about 48 constellations in the northern hemisphere? So you're going to want to know that. Which 2 constellations can be used to locate other constellations? And why will the constellations change over time? What specifically is causing these changes? So make sure you know these questions. If you're not able to answer these, go back and watch again. Make sure you copy down those constellations in your notebook. And have a good day.